In this video, let us see chords, tangents and normals of a hyperbola. You know the equation of a hyperbola in the standard form with its center at the origin is x square by a square minus y square by b square is equal to 1. Let P and Q are the 2 points on the hyperbola. Coordinates of P x1 y1, coordinates of Q x2 y2. Since P is a point on the hyperbola, its coordinate should satisfy this equation. So x1 square by a square minus y1 square by b square is equal to 1. Then Q x2 y2. This point also should satisfy the equation of the hyperbola since it is on the hyperbola. So x2 square by a square minus y2 square by b square is equal to 1. Now right hand side is equal 1. So you can equate the left hand sides. So you equate these two sides. Our aim is to get to the slope of this chord. PQ is the chord. Then we have to get a change in y coordinate by change in x coordinate. For that you take this to this side. So now x1 square minus x2 square is square divided by a square is equal to this minus y1 square by b square you take to the other side. So y1 square minus y2 square divided by b square. This can be written as x1 plus x2 into x1 minus x2 because of this x1 square minus x2 square by a square. Then this y1 square minus y2 square can be written as y1 plus y2 into y1 minus y2 all divided by y square. Now rearrange this. y1 minus y2 divided by x1 minus x2. Then b square by a square x1 plus x2 divided by y1 plus y2. So you are getting the slope of this chord. Now you know the point and the slope. So we can write the equation of the chord. This can be written like this. x1 square minus x2 square is x1 plus x2 into x1 minus x2 all divided by a square. y1 square minus y2 square can be written as y1 plus y2 into y1 minus y2 all divided by b square. If you rearrange this, you can get the slope y1 minus y2 divided by x1 minus x2 is equal to, take this b square here, b square by a square into x1 plus x2 divided by y1 plus y2. So you are getting the slope of this chord. So you know the points x1, y1. So if you know the point and slope, we can write the equation of this chord. Now let us write the equation of this chord. We know the slope and point. So this is a slope point form. Y minus y1 is equal to m x minus x1. So now the one point is x1, y1. Then slope we can substitute. Then this is the equation of the chord PQ chord. Then this chord will become tangent if Q approaches P and then line will touch only at one point. Then x1 will become equal to x2. When Q coincide with the P, the chord will become the tangent. That means in this equation, instead of x2, you write x1. Instead of y2, you write y1. Then you will get the equation of the tangent at the point P, x1, y1. Now when we substitute for this x2, x1, x1 plus x1, that is 2x1. Then for this y2, when we substitute y1, y1 plus y1, 2y1. Then this 2 will get cancelled. Then rearrange this. Take this y1 this side, then b square this side, and then it will be in the denominator. Then x1 into x minus x1 by a square. Remove this bracket. Y1 minus y1 square all divided by b square. X1 minus x1 square all divided by a square. Now you rearrange this. x1 by a square. This minus x1 by a square you take to this side, so it will x1 square by a square. Then here minus y1 square by b square is equal to x1 by a square. This you take to the other side, y1 by b square, so plus will become minus. Now x1 comma y1 is a point on the hyperbola, so it should satisfy the equation of the hyperbola. So x1 square by a square minus y1 square by b square is 1. So for this you can write 1. Now x1 by a square minus y1 by b square is equal to, for this you can substitute 1, because it's a x1 comma y1 is a point on the hyperbola, so it should satisfy the equation of the hyperbola. So this is 1. So this is the equation of the tangent at the point x1 comma y1. So easily you can remember, where there is x square you write x1, where there is y square you write y1. Then you will get the equation of the tangent at the point x1 comma y1. Now let us see how to get the normal. This is the equation of the tangent. X1 by a square minus y1 by b square is equal to 1. Then we have to get the equation of the normal. First let us rearrange this. A square b square LCM. Then when this is divided by a square, then b square x1 minus, when you divide this by b square, then a square y1 is equal to 1. Take this to the other side, so 1 into a square b square. Then this is the equation of the tangent in another form. The equation of the tangent we rearranged and we got the equation of the tangent. Then for getting the equation of the normal, we can use perpendicularity condition. So if this is the normal at this point, this 90 degree. If two lines are perpendicular, product of their slope should be minus 1. So for getting the equation of the normal, we have to interchange the coefficients of x and y and change the sign of 1. So here either x or y. Here coefficient of x is b square x1, that is given to y, b square x1. Coefficient of y is a square y1, that is given to x. Then change the sign for any one of this. So this minus will become plus. Then constant will be different. Instead of a square, b square, k. Now normal also passes to the point x1 comma y1. So for this x we can write x1, for this y we can write y1, so you can get the constant. Then for this k you can substitute this a square y1 x plus b square x1 y is equal to k. For this k we can substitute this. So a square y1 x1 plus b square x1 y1. So in this you can see x1 y1 common, so you can take that outside. Then a square plus b square. Now take this x1 y1 to this side, so it will come to the denominator. So when it is taken to this side, now y1 so it will get cancelled. So a square x by x1 plus here x1 will get cancelled. So b square y by y1, b square y by y1 is equal to a square plus b square. So this is the equation of the normal at the point x1 comma y1. So this is the Cartesian equation of a tangent of a hyperbola. From this easily you can get the equation of the normal. Here you can see x1 by a square, y1 by b square is equal to 1. Then here it is a reciprocal. Instead of x1 by a square, now a square by x1. Then here instead of y1 by b square by y1, then minus, it is plus here. Then constant is different. Try to remember the constant. So a square plus b square. So easily you can get it from this. So you need not remember this. From this you can get it. Then parametric form. Parametric form also from this you can get. You have to remember the parametric equation of a hyperbola. Parametric equation of a hyperbola is x is equal to a secant theta and y is equal to b tan theta. So in this you substitute, instead of x1 you substitute a secant theta. Instead of y1 you substitute b tan theta. Any point on the hyperbola is given by this relation. So x1 a secant theta and y1 is b tan theta. So after substituting, you cancel this a square. So x secant theta by a minus y tan theta by b. This b square b cancel it. It will get cancelled. So this is the equation of the tangent in the parametric form. Then for getting the equation of the normal, here you substitute. For x1 you substitute a secant theta. For y1 you substitute b tan theta. So here a square a. So after cancellation it will be ax by secant theta plus by by tan theta is equal to a square plus b square. So in the equation of the tangent you can see here secant theta by a, but here it is a by secant theta. Here tan theta by b, but here it is b by tan theta. So you have to take the reciprocal, and then this, instead of this minus, you have to write a plus, then constant instead of 1, a square plus b square. So if you remember this, you can get from this equation of the normal.